Welcome to today's class. In today's class, we continue with our Lewis structure and its application. Today's class will focus on the shapes of molecules or ion. The shape of a molecule or ion is the geometric structure of the molecule or ion. The shape of molecules or ion are determined by isoelectric rule. Isoelectric rules simply state that molecule or ion with the same valence electron possess the same shapes. Now, since we have determined the hybridization of a molecule using Lewis structure, we will simply apply the rules of hybridization to determine the shapes of molecule. Let's look at rules of determining the shape of molecules or ion. Now, the first rule we consider is all molecules or ions with two atoms have a linear shape with a bond angle of 180 degrees. Now, look at carbon 2 oxide, 2 atom. Look at the hydrogen molecule. Look at oxygen molecule. Look at chlorine molecule. Look at CN-. One thing is common with all these species: they contain only 2 atoms. Any species that contains only 2 atoms will have a linear shape. So the shape of CO, H2, O2, Cl2, Cl-, every one of these species will have a linear shape and their bond angle will be 180 degrees. So all molecules or ion with 2 atoms have a linear shape. Now let's look at the second rule. All sp hybridized molecule or ion have a linear shape with a bond angle of 180. Now, from our previous class, this is the shape or structure of carbon 4 oxide. You will discover that the hybridization of carbon 4 oxide is XP. Because carbon 4 oxide has an hybridization of sp, the shape will be linear with a bond angle of 180. Now, carbon disulfide also have hybridization of sp. Because the hybridization is sp, the shape will be linear and the bond angle will be 180 degrees. So all molecules that are sp hybridized always have a linear shape. Now, all sp2 hybridized molecule or ion have 2 possible shapes. Number 1, if there is no lone pair electron, the shape will be trigonal planar with a bond angle of 180. In our hybridization class, you can see that the hybridization of BF3 is sp2 hybridized. Now, if you look at the structure of BF2, you will discover that the central atom has no lone pair electron. Because BF3 is sp2 hybridized without a lone pair electron, the shape of BF3 will be trigonal planar and the bond angle will be 120 degrees. So any molecule that is sp2 hybridized that does not have a lone pair electron on the central atom we have trigonal planar as its shape, and the bond angle will be 120 degrees. Now, if the molecule is sp2 hybridized and there is a lone pair electron on the central atom, the shape will be angular, bent, or V shape. A good example is sulfur 4 oxide. Now, sulfur 4 oxide is sp2 hybridized with a lone pair electron on the central atom. Because sulfur 4 oxide is sp2 hybridized, with a lone pair electron on the central atom, the shape would be angular, bent, or V-shape. And the bond angle will be less than what? 120 degrees. The next rule, all sp3 hybridized molecules has three possible shapes. Number one, if there is no lone pair electron on the central atom, the shape is what? Tetrahedral. And the bond angle is 109.5 degrees. Let's look at methane. Methane is sp3 hybridized without a lone pair electron on the central atom. So, methane is sp3 hybridized. Now, all sp3 hybridized molecules without a lone pair electron on the central atom will be what? Tetrahedral in shape, and their bond angle will be 109.5 degrees. Or if there is one lone pair on the central atom, the shape will be trigonal pyramidal or distorted tetrahedral with a bond angle of 107 degrees. A good example is ammonia. Ammonia is sp3 hybridized with a lone pair electron on the central atom. Because ammonia is sp3 hybridized and there is a lone pair electron on the central atom, the shape will be what? Trigonal pyramidal or distorted tetrahedral. The third rule is that if there are two lone pair electrons on the central atom, the shape is angular, bent, or V-shape, and the bond angle will be 105 degrees. A good example is water. Water has two lone pair electrons on the central atom and two bond pairs. So the hybridization is sp3 hybridized. Because water is sp3 hybridized with two lone pair on the central atom, the shape will be bent, angular, or V-shape, and the bond angle will be 105 degrees. Thank you.